Okay. Well, good afternoon. I'm Brian Winkle, the director of Semiote, and I'm pleased that you're with us today. We have a very, very interesting and applicable program on practical guide for incorporating ethical reasoning into mathematics courses through modeling problems. This is a group that's evolving and hopes to embrace more of you, and we're glad that you're with us. We have three of the leadership team. That's Feryâl, Korana, and Jeremy from various parts of the country, and I'm going to turn the program over to them. But I will say that if you have questions, you can put them in the chat. We'll be watching that. We'll also have time for questions at the end. This is a 90-minute session. It's being recorded. So you don't need to take notes. You can do the casual thing. And in a few days, we'll have the recordings up and let everybody know where they are at Semiote. So take it away.
Thanks, Brian, both for the invitation and introduction. I'm Feryâl, as Brian mentioned. And we will be talking about incorporating ethical reasoning into mathematical modeling courses, but I'm going to change that in a little bit before I give it away, though. We want to start by introducing ourselves and our institutions, our backgrounds, so that you know a little bit about us, so you can contextualize what we're talking about. And I also totally forgot to mention that this is joint work with Erin and Rohit, who had spoken at the expo earlier, and their talk is available. Some of it is a little bit of an overlap, but you can watch their take on this as well. But Erin is from Eckerd College and Rohit is from University of California, Davis. So a little bit about ourselves. I'm at Grand Valley State University in West Michigan, US, and we are a regional public university. We are listed as doctoral granting institution, but we have like 2 doctoral programs, more master's programs. And in the math, we actually don't have a master's program. We're just like undergraduate only. In terms of our classrooms, we are very small, like 30 is the maximum for my class sizes. And upper level classes, like math major only classes, are more like 24 and sometimes 10 to 16 usually. And in terms of our teaching style, was there a question? Sorry. Okay. We are active, like I don't want to just say just active learning. We do a lot of innovative teaching in our department. So there's active learning, there's master-based grading, and then undergraduate research incorporated into courses, all sorts of crazy things. So that might be different at your institution. I give all this background because when I do these things, students are like, oh, okay, there's something new, but I'm used to doing new things anyways. So that might be one thing to keep in mind. And then I'll let Jeremy and Korana introduce themselves. I don't know, start with Korana maybe?
I'm Korana Burke. I'm at UC Davis. We are a giant institution, about 40,000 students. And as such, I tend to teach classes that are way, way, way bigger than Feryâl's. So when I consider my class to be a small class, it's usually about 90-something students, but most of my classes are usually on the order of 200, 300, or 400 students. And we have a variety of classes, and it also means that we also have a variety of majors taking our classes. So what we're going to be talking about today is going to be applicable to not just the math majors, but also all sorts of majors that I, for myself, see at UC Davis, anything from economics to bio to engineering to even agricultural sciences. And Jeremy, go ahead.
Hello, I'm Jeremy Shaw. I work at Oregon State University-Cascades campus. So we're a part of the Grand Oregon State University campus, but we're sort of a satellite campus and a four-year school at the same time, depending on what aspect of the school that we're trying to promote to the outside. But we're small enough that there are exactly 4.25 math people, and that includes math and stats and business, since we teach all those across the disciplines. We're small enough that we have about 1,250 students, give or take. And we just got approved to have a math minor roll out next year. So, and for the moment, we're just supporting other programs. But as our school is kind of small, it's not difficult to cross disciplines and run into the chemistry instructors, the bio instructors, the engineering instructors, the physics instructor. So I have a chance to talk with all of them just by passing each other in the hallway or meeting up somewhere, and can share what I've been doing that helps the students taking my classes, which are in those programs, and then I can help them in their careers going forward. So we're small enough, it's like the opposite size of a UC Davis. If we're trying to compare sizes.
And I should have said we're right in the middle, like 20,000, about 20,000. So now that we introduced ourselves, we're going to ask you to the same thing. So we're going to start by asking you what are you hoping to get out of this webinar and what is your context. And we'll then jump into our part. We'll start by describing what we mean by ethical reasoning, so we're all on the same page, and then why we should include ethical reasoning, or why we should not exclude ethical reasoning more correctly. And then we'll mention our goals of the framework, why we're using the goal, or why we're using a framework format, and what's the purpose, how does it help. And then we'll give a general description of the framework and then apply to specific problems. And we'll finally end with reflections and hopefully some takeaways for you. And there will be time for questions and answers at the very end. Okay, so we'll ask you all to put in chat the answers to these questions. And we didn't think about like asking the institution, so your name and institution, we could start with that. And then what are you hoping to get out of this webinar? And which classes do you teach? Are they calculus only or differential equations, or are they mostly service courses or math majors only? Whatever you want to put in there. And then how big are your classes? As you saw, we have a range of sizes in our group, and then we'd like to see what you're thinking about. We will be putting you into breakout rooms at one point for you to practice. Now that I'm thinking, that might not have been in the outline. Oops. And we might be splitting you up based on diversity of schools and things like that. And I can tell you in the meantime what I was hoping to get out of. We actually, our stories, we met at a workshop last summer, which was about incorporating ethical reasoning into math courses in general. Hi, Eric. So, like, why did I get involved in that one? Why was I interested in it? Well, part of my thing is I have been thinking about doing this for a while. I already had a tiny little thing about academic integrity, a small quiz. I've been using that for, I don't know, 20 years. Because we're not just teaching math in our courses, we're teaching our students to be responsible citizens, global citizens, local citizens, and responsible adults in their workforce. And I also say in their like personal life. So if their wives come and later say, hey, your teachers did not instruct you properly, I don't want to be responsible for that. Wives and husbands, whichever way. And I'm like, oh yeah, I've been thinking about that. But then last year in February, we had earthquakes in Turkey. And there's like a lot of things surfaced about how things weren't done properly. There were so many checks that failed at multiple stages. And it's a global issue in the systemic issue in Turkey, a little bit more so than here. So here you see Enron once in a while, and then VW, and I don't remember whatever other things. But in Turkey, it's a little bit more systemic, and I'm like, what's my role in it? I can't just, at one point I was not the adult, but at this point I'm like, oh, I guess I'm the adult around. So what's my role in this? How can I change things a little bit? Like, okay, I'm not teaching necessarily the engineering classes, but what can I be doing? And I'm not able to go all the way up. Cool. I'm seeing, learn about how ethics plays a role in mathematical modeling and how I can learn about cases and issues. Want to hear more about ethics generally. Lots of calculus, linear algebra, differential equations. Yes, calculus, differential equations. I haven't taught linear algebra lately for some reason. Eric from Fort Lewis College. I'd like to know what assignments are given and how they are assessed. I teach the whole undergraduate math curriculum. Cool. 3 to 30 plus. Ooh, 30 plus is probably just around 30 because you're not using 40. So I'm gonna go with that. I'm just making an assumption. I'm not sure. I'm hoping to get ideas for specific ethical situations to discuss and learn about my unknown unknowns. Eastern Michigan. Hi, Andrew. And 12,000 undergraduates. Okay, class size is less than or equal to 34. Yes. I went too far down. And then Calculus 1, Calculus 2, math modeling. That's a good class. And data science related classes. Ooh, those are cool. Not ChatGPT stuff yet. Yay. Adam, cool. Ethical considerations in mathematical models is a topic of interest to me and is relevant to past and current research about social access. Oh, I'm having a hard time with the scrolling. Can I make it bigger?
We will have, it looks like we will have a great set of breakout rooms for you later on. I'm really excited about this.
And I want to learn how ethics is significant in teaching in area of artificial intelligence, and then learn more about how you incorporate social moral aspects around mathematics teaching. Cool. How students react. Yay. We will get to that at the end. Perfect. Thank you all for sharing your thoughts. We are excited. I think I'm not sure we're hitting everything, but we're hitting most of those things. So we're good. Okay, why is my down not working? So what's our like one line idea of what we're doing? We're proposing to add the framework that we're using is adding ethical reasoning questions to existing mathematical modeling activities or problems. So if you think about incorporating, that's how we're thinking about doing it. It's just we're incorporating them by like taking a regular problem. We're not writing anything from scratch and adding questions to it. But then this is what we said initially. Then I realized, wait a minute. Nope, I'm going to scrap all of that. What we're doing is we're putting back the ethical reasoning questions that people asked, either before creating the mathematical problem or during the creation of the mathematical problem or after, into the modeling problems that we have in our textbooks. So we're putting those back. They were already there. It's not that they were non-existent. Anytime you are involved in a real life situation, you are thinking about ethical implications. So we're putting those back in to our problems. But let's go back to the ethical reasoning. So what do we mean by ethical reasoning? So ethical reasoning involves multiple steps. It's the process of recognizing ethical issues, thinking through ways to resolve these issues using multiple perspectives, making an ethical decision, and implementing and reflecting on the outcome. Okay, so we're counting 5 steps, and if you count implementing and reflecting in 2 steps, there's 6 steps. So we are basically asking ourselves, and hopefully you also, to think about how we can address these 6 steps of the ethical reasoning process in our classes. And part of these also overlap with critical thinking skills. And I want to also clarify, we're not advocating teaching general ethics in our math courses. We're not suggesting that, hey, we should just teach standards of a professional code, whatever professional society you want to pick. We're also teaching not morality. We're not teaching morality. That's something else. We're not doing any of these things. We're just focusing on the critical thinking / ethical reasoning aspects of the problems, of the mathematical modeling problems. So, okay, this is where, move this a little bit. Why are we advocating this? That's one of the things. And I said it already at the beginning. I'm like, ethical reasoning is already part of mathematical modeling. So if we're teaching mathematical modeling, too much, there we go. If we're teaching mathematical modeling, then we have to teach the whole package. We can't just say, oh, we're only going to teach the math part of mathematical modeling because the other part is somebody else's responsibility. Who's responsibility? It's not clearly the philosopher's responsibility because philosophers don't know how to do mathematical modeling. If we're teaching mathematical modeling, we're teaching the whole thing. And this is my teacher perspective. From a more philosophical perspective, Ernest is one of my favorite people. So from his 2019 article, he says mathematics teachers share the obligation to consider the ethical consequences of different pedagogies and selections of content and representations of content. So if we're teaching mathematical modeling without any ethical reasoning, we're making a selection of content and representations of content. And that gives a signal to our students about what we consider important, what maybe they should consider important. I mean, I never listen to my teachers, but if there are the students who are using us as role models, then they would look at it and they say, oh, I only need to pay attention to the math. So we are giving a message by making that choice. And in my opinion, in our opinion as a whole group, we need to incorporate the ethical reasoning back into our mathematical modeling problems. And more practically, why do we really need to teach this? Well, our students' careers, especially for service career, like service courses or applied math majors, those types of students, they're going to involve using mathematics in applications in real life. They're not just going to be solving theorems. Even those students who are solving theorems, doing theorems, or just teaching, they will be doing ethical reasoning. So their situations might be slightly different than mathematical modeling problems. So if our job is to train our students for their future careers, and if that includes ethical and responsible reasoning, then we should teach that part of the mathematical modeling as well. And the other bonus, some of us could see this coming, I didn't see this coming, this actually also helps with teaching the math, because by putting the ethical reasoning questions in, the problems become more relevant to our students. And then they can see they are more invested in those topics. And as I mentioned, some of the skills of the ethical reasoning and critical thinking skills overlap. So if we're teaching ethical reasoning and asking students to identify your assumptions, well, that's part of critical thinking skills. So we're getting a bonus skill about something that's important to the university and to the general public. So now we're using a framework format, which we will explain in a little bit. But why are we using a framework format? Why are we not just saying, oh, let's create a few case studies and then have students do those things? Well, because we want our framework, or the way we're incorporating ethical reasoning into courses, to be course and mathematical maturity independent, mathematical maturity in terms of our students. So we could have problems in a pre-calculus intermediate algebra class that uses ethical reasoning, but also in a 400 level numerical analysis class, or wherever things are applied in an upper level class. And we also know that faculty are overworked and overwhelmed. We want our framework to be easy to use, and it should not require a lot of commitment from faculty members. And this also ties in with the, hey, if we use a framework format that uses existing questions, we don't need to create new content. That makes life easier. And it's not just in terms of time, but also in terms of material, because Like, well, I'm going to run out of ideas for case studies at some point. And all of this ties to, we want our students to develop this skill to use in their future lives, not just, hey, they're going to pass the class and then get an A or whatever it is that they're going to do with that course. We want them to automatically think about, okay, wait, I'm doing a mathematical modeling problem. I'm doing some data analysis. I need to think about the ethical impacts of this thing automatically. Because if you know, back in the days, I think it was in 1990s when the writing across the curriculum movement started, students were resistant. When I asked them to write, explain your answer, they, especially in math courses, why I found a number, why do I need to write? Why do I need to explain it? But the more they did it in earlier classes, that I don't even have to tell them to explain. In the 400 level courses, they automatically do it. So same thing, we want them to practice ethical reasoning from the early classes up until 400 level classes or whatever the upper level, 4000 level classes at your institution regularly to develop those skills. And now what's our framework? So we're basically taking an existing problem, mathematical modeling problem, and then adding some prompts to make this mathematical problem more relevant to real life, more real life-like. And the way we do that is by identifying, I mean, this is our perspective of a mathematical modeling problem. So the meat that we normally see in our mathematical modeling problems is the mathematical solution of the model. So maybe there is a model that students are using, and then there's some parameters or whatever, and then they are doing some computations and they're getting some result. So that's what we usually see, but there's a background and context before it, so which might sometimes come up in projects or more involved problems, labs, those types of things. But there is a background and context that students identify which model fits best, and then how do I determine these parameters? And there is a reflection after they do their computations, evaluating the results. Do they fit? What do they mean in terms of the real life context? So usually we have the mathematical solution of the model part, the meat in the middle, given to us in our textbooks, our own problems from before. And what we're suggesting to do is adding the problems related to the background and context and the reflection. Remember the 5 steps of the ethical reasoning process. So we are basically suggesting to add prompts in these 2 parts to make the ethical reasoning come back alive in our problems. And Jeremy will tell you about how to do that, starting with a specific differential equations problem.
All right. So this example, we put in the slides to be our first one of 3 examples we'll show you before the breakout session, is just to give you an example of a problem that could have come from any textbook that you might see, like a traditional textbook, problem 32, for example. So here we have a problem about Newton's law of cooling. And so if an object is at temperature T and is immersed in a medium having a constant temperature M, then the rate of change of T is proportional to the difference of the temperature difference M minus T, which gives rise to that famous differential equation. So if any of you teach differential equations, you probably already knew. I didn't have to explain it. For a student, we have to kind of showcase what the model is. So this is the background as much as it is. And then there are a couple of mathy questions. Solve the differential equation for T. And then after students do that, they can then do something further with it, like this part B shows. Thermometer reading 100 degrees Fahrenheit is placed in a medium having a constant temperature of 70 degrees. After 6 minutes, the thermometer reads 80 degrees. What is the reading after 20 minutes? So for me, in my experience teaching differential equations in the numerous textbooks I've seen at the various levels I've taught, this is kind of a standard modeling problem. As much as real life as it goes into, there's not a lot asked about it except do the math, on to the next. And so with the framework mentioned on the previous slide, which us 5 as the contributing authors here kind of found out ourselves in a breakout session of our own, so maybe breakout sessions do work, was what's missing from here? What can we say that adds to this that allows students to now think about where this could be used, who's responsible for the model, and the other kind of related questions. So other modeling questions you might encounter might even actually say something like, this one's pretty generic, doesn't even have a particular context. Like, what is the medium? Is a bread being put in the oven, or are you trying to heat some object while you're forging iron? Or we don't know what this is. And so let's see what some of the possible questions we can use. We've prepared a few next couple slides. So in terms of that framework, we broadly thought of a model as three kind of generic parts. So if you thought they could be finer divided or divided up in a slightly different way, that's acceptable. Of course it is. We just thought in three broad parts. And so these 5 examples here, although 5 examples is a lot to add for any question for students, so you probably would not ever think to add all of them, but maybe just to see an example of what you can actually add that touches on the ideas of the background and the reflection part. So let's say we ask students, to what real-life context that you care about can this model be applied? What are possible questions that could be answered that would have an important impact in this context? Maybe that could be part A before you do the math. Or you can add this, we jokingly call part E for ethics. So you can do some math and then it's just part E, if you want to put it there. So it can go anywhere you think works with the flow of the problem. You can also ask, with the right context provided, how would you test the accuracy of this model? Do you think the model is reliable in its predictions? Are there reasons to suspect that the rate parameter might not be constant? So that might question, is the model even reliable over time? We just have students say, here's the equation, it works for all infinity time, and there's no reason to question it. We don't have to question where it came from, why it exists, and if it's going to be valid in times beyond the domain of being considered. So what challenges do you foresee in the process of estimating the model parameters? What potential trade-offs might be made when estimating these parameters? So do students think of these? Do textbooks actually ask those? And how about these? This is more on like the reflection side of things. Maybe this could be towards the end after the math has been done, and it would be up to the instructor to decide of these like 10 bullet points. That's too many. I'm going to go through A through Z now. So we would recommend instructors pick a small selection that suits what they want to do in the question. And maybe we can ask this first one. List at least 2 different business, industry, nonprofit, or government organizations who might use this model. For each one, list at least one question they might be trying to answer. So we would imagine with all of these questions, I'll read a few more of these, but just to discuss some, is that we want to ask these of students. But if we think about it, should we just put this on homework assignment number 1 that they take home, and then there's no like prior discussion or ways of explaining to the student who've never done this before, how are they meant to answer this? So for these kinds of questions, our main idea to drive along with the framework is, while trying to spread this kind of questioning throughout a course in even way with multiple different types of assessments, or in just an even spread around the class, we start with some kind of in-class discussion or lecture-driven example. So that way, when the instructor's standing up in the front and prompting students to ask, name some entities who might use a model like this, and then they freeze. I'm like, I don't know, because they're never had to stretch beyond that, their limits in that regard before. So in the beginning, you can try to ask them, what are the possible consequences if this model is inaccurate? What entities might be affected? So they'll consider, maybe the business that is using this model, which are using to forge iron, which is then sold to make parts, which is sold again, maybe to make computer chips, some sort of long chain of decision-making beginning with this moment here. Students can then discuss aloud with each other or in the classroom, guided by the instructor, what kinds of policy decisions might be made using your results? What entities might be affected by these decisions? So it'll be hard at first. When I showed this to students, they basically said, I don't know what I should say here. Even though I know what you're asking, I don't know kind of what broad scope I'm thinking about that can answer this question. So they just needed to be pushed a little bit on the edge to let them see that maybe we can consider the businesses, the other industries involved, the natural resources that come into being used in this process. And so maybe that means the process of mining the iron going into this forge. Is that an environmentally economical process? Are there harms being done to the environment in all the decisions that made it to get to this point where you can use this model? From the perspective of an organization using this model, is it better to overestimate or underestimate? What are risks to think about? How would you revise your model in order to do this? And the last one we provide as a sample, this is not an exhaustive list, even though it seems really long, not exhaustive. What further questions could you investigate with this model? What are some potential benefits and harms that can come from this? So how often have you seen anything kind of like this a lot in modeling problems? For me, it's like a rock is thrown in the air. Here's the equation using -16 t squared, or something goes on from there, and find the time when the rock hits the ground. Well, a rock is not very life-shattering context. So maybe it could be a rocket is being launched into space. Maybe the context can be for a problem that's a bit more realistic. And then we can ask students questions that are adjacent to there. They're just waiting to be added, but not normally considered about. So can you go to the next slide?
Okay, so I'm going to take over. So I tend to teach a lot of our pre-med students, and we use this wonderful textbook, Biocalculus from Stewart and Day. And this is a standard problem that occurs in that calculus problem, but but I also like the problem so much that when I teach differential equations, I also bring up this problem where you have three connected lakes. So we're talking about compartment models, which is a standard thing we talk about when we teach differential equations. And for the simplicity, you have equal volumes, they're interconnected, and then something spills into one of them, and you want the students to write down differential equations. You lead them through how to reduce the size of the system from 3 by 3 to a 2 by 2. You ask them to determine the stability or the equilibrium, find the solution for the initial value problem, and look at what happens as t goes to infinity. And when I'm teaching, usually our engineers and math and physics majors, they're content with these types of problems because these are the types of problems that they're usually used to. But what happens is when I'm teaching my pre-med and my bio students, they're already having hard time seeing how math is relevant to their lives. And now they see something that is blatantly, they know that it's not going to be how it's going to be exactly in real life. And in introducing ethics and ethical reasoning into this kind of thinking actually allows me to bring this closer to them and get them to really buy into understanding why is it important that we know how to solve these types of problems. So for example, when I put up this problem, we usually have a conversation. Does it make sense that we're making these assumptions? And different classes will raise different things that don't make sense. Sometimes students will be like, how often are the lakes really like all three equal of equal volume? Or is the water really flowing at the same rate? And are we really, is it really reasonable to say that none of the pollutant settles out? Well, maybe if they took a lot of chemistry, maybe they'll say something along the lines. Maybe the pollutant reacts with stuff in the environment and then becomes inert, or maybe we are pumping it out. Maybe we're trying to clean it up, because I also have environmental science majors in there. So starting to think about and asking questions along the lines that Jeremy was bringing up allows the students to now view the problem as relevant to them. And the beauty is that the questions that Jeremy showed for you earlier are apply really well to the Newton's law of cooling, but those same questions I could be asking to this problem, and then the students will internalize them slightly differently, and that is fine. The whole point that we are trying to make, not just with this presentation, but with all the other things that we're talking about as a group, is that different people will look at the problems from different perspectives, and we want them to look at it from different perspectives. So Feryâl, if you don't mind going to the next slide, so asking the students which assumption does the model make that might not be valid in real life is also then a great opportunity to open up how can we improve the model. And even though my students in biocalculus might not know how to solve that improved model, I have now opportunity for them to reflect on each term in the system of differential equations that we wrote down, and then be able to understand what each term means. What terms would I need to add? Which terms would I need to change? So they are now getting a lot more comfortable with actually writing down the modeling, even though in that particular class, we might not have the tools to solve those models. They can also think about which measurements would they take to test the validity, because a good model is the model that can be tested. And so they can think about how they can change these equations, and then they can think about what if you go to the next slide, I'm gonna bring up exactly the same slide that Jeremy had in the reflection. We can think about who is affected by all of these choices that we are making. So in engineering, if I'm talking to engineers, they might think about one thing, whereas if I'm talking to environmental scientists, they might be thinking about the other thing. And all of these are important things that we want our students to be reflecting about, and we want our students to be thinking about. And in that process, they're learning valuable skill of how to write a mathematical model, what everything in mathematical model means, and then also think about what if, I'm using this mathematical model to do something important. Cleaning up a chemical spill in lakes can be very important. And the students, here in Davis would think about it different way than the students in Michigan or the students in Quebec, because they will have a local lake that they might be thinking about, and that's great. So if we go to the next slide, this is also, yes, it is bio aspect, but this is a slide that our colleague Rohit has been using in a class that is geared towards, for now, it's geared mostly towards data science and economics and managerial economics students, where we give them some data sets and we ask a very standard type of a question based on data set. Let's build a model. So we ask them to plot a linear log and linear log linear plots of the data, and then based on those plots to decide which of the models is correct one. Is it a linear, is it exponential, or is it a power model? And then based on these kinds of plots, then the students, you can ask them various types of questions about population of the cranes and so on. But what we did is we asked the students to reflect on you can go to the reflection. Here's the prompt that they were given. So who might be interested in your predictions of crane populations and for what purpose? If your predictions were too high or too low, what would the consequence for the people using your predictions? So this is the actual prompt that was given to the students this past year, and we can see now how the students are responding to this. So this is one example response where it says, wildlife protection organizations, conservationists, animal enthusiasts, ecologists, zoologists could all be interested in our predictions. So if you just look at this first part, students are already thinking about all sorts of different entities that might be interested in what you're talking about. And then they say, if our predictions were too high, it could result in people overestimating the stability of crane populations and not allocating sufficient resources towards their preservation. You can tell that this is econ person. And then, however, if our predictions were too low, it could cause undue alarm over seemingly decreasing crane populations, which would result in resources being wasted on the preservation of cranes, while they could be better put to use for animals that are actually in danger of disappearing. So something like this is, what I was never asked when I was given these types of questions when I was a student. And it's something that I frankly am a little bit upset that I was never asked until I started interacting with people who also think about ethical reasoning. And it's clear that this now problem is, for this student who wrote this kind of reflection, this problem hits home much more than if we had just asked them a standard question about, here's the data set, figure out, figure out the model and make predictions. So what we are arguing is what Jeremy alluded earlier, is that it's really easy to all of our mathematical modeling types of problems to add this part that we're calling on the next slide, E for ethics. So in this framework, you can always add this part E to all your problems, where you can say, consider now the context of this problem. Or you can ask the students to even consider the context of their choice. It doesn't have to be in the Newton's law of cooling, it doesn't have to be iron. Maybe the students will come up with a different context that will be important to them. And then you can ask them what assumptions are being made in this problem regarding real life context, how you can verify the reasonableness of these assumptions, and you list some parties that might be effective, either positively and negatively, because we want them to think about both directions. We don't want them to think about just the negative. We want them also to understand the second side of the problem. And we want them to think about how each of the parties will be affected. So going on now from here, I'm going to turn it off to Feryâl, who's going to talk about yet another example, which is not differential equation example, but it's still how you can use this kind of framework in a math class.
I totally forgot that I was muted. It's Korana. So I'm using if you're familiar with the active calculus series, we have active calculus, single variable calculus, and multivariable hosted, it's not hosted, developed at Grand Valley State University. And I was teaching Calc 3 this semester using the multivariable calculus book. So this is one of the problems from my class. I'm going for the easy version. Now, not because I want it to be easy, but because I'm really horrible at choosing contexts that interest students, because the stuff that I'm interested in, they are not interested in. I'm a little bit of too nerdy for them. So I'm gonna let them figure out the context if it's not available, or even if it's available, I'm not gonna think about what they might be interested in. I'm just gonna put this like one single item at the end of my questions and then have them answer that one regularly, because remember, we're trying to develop consistency. I think it works better if they're always thinking, who might be affected, or I changed it, what parties might be affected. And I'll come back to why I changed it in a minute. So this is my problem. The book uses this specific table, I think 2 or 3 times throughout the sections on partial derivatives, it's second order partial derivatives. So there's the heat index function, there's some values, and they use the limit definition using the table values to estimate the second order partial derivative at a point and explain what it means. And they do the same thing with the second order partial, they do it with the temperature second order derivative, temperature or humidity second order derivative, and the mixed partial derivative. And students are good, they figure out like how the tables work, they can find these values. And then at some point I actually asked them, does that match your real life experience also? This is something they can easily do. Yes, it does. They're really good at that. And now what are the 2 assumptions being made in our solution regarding this context? That was one of the homework problems this semester. Was it homework? Yes, it was homework. I think it was homework, or maybe it was class discussion. I don't remember. They said some things about somebody might be working out in the field, or you're maybe contractor and then you have workers doing construction work. You need to be aware of the heat index being, because we're using it to estimate some values and then doing some linearization. I think that was the context, additional context that I had put. Like we might have workers we need to watch for. Somebody was just like, I might be a forecaster and like I might be giving incorrect information in my forecast, and I might lose my job, those types of things. So they were thinking about the different impacted parties. And I'm going to go back to what I said about who might be impacted. I was really bad with this in the first semester, and then I caught myself. I don't use who anymore because I use the word who might be impacted. My students were mostly thinking about humans, about impacted parties, and even, I think, even companies with that wording. So they weren't really thinking about wild animals. That's my thing. What about wild animals? What about the nature? So when we had class discussions, if nobody had brought up the animals or the nature that as potential impacted parties, I would be the one. So I had some students who went from my Calc 2 class last semester to Calc 3 this semester. So we did this in-class activity discussion one time, and somebody put dolphins in there because it had something to do with the bridge. And interestingly, I'm just like, wait a minute, are those one of my Calc 2 students from last semester? Sure it was. So they learned that they need to think about animals. But that said, though, I think after that experience, that one single example, later I had a problem about trusses, engineering trusses, and I didn't give them the context. I asked them to put the context. It's interesting, some people used bridges, and they mentioned the wildlife. If the bridge collapses, what will happen to the wildlife? And sadly, one person actually mentioned that, I think one or two students had mentioned that construction workers could be working on the bridge, and if the bridge collapses, construction workers might lose their lives, and kind of predicting, unfortunately, the Baltimore bridge disaster later this semester. So now that if my down arrow works, no, it can't move. Okay, there we go. So now that we gave you some ideas of how to do this with different examples, well, what we do when we teach is we give the general concept and we'll let students work on it. So we'll ask you to do the same thing. So we're going to have you go into your rooms. Before you join, I'm going to mention that we have files for each group. So if you can go to this, was that in the chat?
Can you put that URL in the chat?
Yeah, can someone put it in the chat? I don't have a
Yeah,
way of,
I will.
yeah.
So I'm working on it.
We'll put that link on the chat or in the chat, and then I lost it. Where did it go? There we go. So if you go to that page, it's a Google document. There is different pages for each subgroups, and based on your room number, pick that page, and then we will join you. I mean, your room, for your page, there's going to be instructions about what to do with the two problems that we gave you. Don't need to solve the math. Just to clarify, there's no need to solve the problem. So we're only asking you to add ethical reasoning prompts relevant to your context and your students' context that you might be thinking about. And we'll ask you to come back and then share what you've done in the group. Do we have everybody back?
Yes, we do.
Perfect. Great. Thank you all for engaging in wonderful conversations. I dropped in group 2. I don't know what group 1 did, so I'm not sure. But group 2 was having a really interesting conversation. And at this point, Jeremy will take over and ask you to do some share outs.
Like trying to coax students to share in a classroom, I'll try to do that with you. If you're willing to share aloud for the whole group to hear, what were some of the things you discussed about those problems, and what your takeaways from that? So what context did you consider for the first problem or the second one? And then what were your considerations when deciding what prompts to add? So I guess just what were your results after that session? You can start with group 1 if you like.
Yeah, I guess I can talk for group 1.
Sure.
And let's Adam, unless you want to talk, you can go for it.
You can go ahead.
So yeah, so the first problem, I don't know, did everybody have the same problems? Our first problem was about hormone
Yes.
secretions in the blood. Okay. So, I guess we thought about maybe it could be used with with hormone replacement therapies or with insulin or thyroid medications. We weren't I don't know. I wasn't 100% sure if that model was supposed to be used that way, but I guess we could kind of see it being used that way. Um, and yeah, did you want me to go into the other things we talked about with that? I
Sure.
forgot.
Thank you.
I got to hear it being in your group, so I'm gonna make
Okay.
you share, if you will, like, no, again, like prompting a student.
Okay. Um, yeah, we were curious about the I guess some of the questions that we had about this is whether it worked for different body sizes and what about kids or infants. And we're also curious about the units or the parameters and how they could be estimated. And of course, one of the questions we would ask is what the potential harms would be if the model was used to prescribe, and if the model wasn't accurate and it was used to prescribe medication. I don't know if there's anything else that we didn't get written down, but I think that's everything that we talked about with that first one.
Mm-hmm.
Do you want to hear the second one?
I can share what you'd like, and if you want to summarize it, what was there anything that was important to the group that you thought?
For the first one or in general?
In general.
Oh, in general. I think we actually kind of ran into the feeling that we didn't know for sure enough biology to feel like we were real confident about what the model was supposed to be reflecting. But it did definitely made us ask a lot of questions about what, kind of where, how the model could get used and ways it could go wrong.
So it behaved
Mm.
exactly like our students do when we give them a math problem.
Yeah, it's a little it's a little daunting to just to be presented with this medical this equation that is something to do with medical things, medical um applications.
Mm-hmm.
So
I think it's fairly common for math students to be presented with problems that have like a token context attached to them that you don't really need to think about because we usually only ask about doing the math part. Having to actually drill down into what it means and what you might use it for, it definitely feels like you're being put on the spot.
Yeah, so just since I think I'll just speak up for group two also.
All right.
I think the first thing that you noted is right that it says a hormone, and the question that, and then you said, oh well, what if it's insulin or some, and is melatonin actually a hormone? I'm not sure. Maybe it's just it's a neurotransmitter of some sort. But in any case, naming the hormone and deciding what its effects are, like what does this hormone do, changes the problem pretty drastically. And that right where the problem as written, which is like Adam said, is kind of typical of math textbooks for these service courses that are being taught to engineers and medical students. They're here's a context, now you forget the context. And I think it's interesting how what a difficult time we actually have creating prompts for these questions that have anything to do with the context.
Now, those questions you saw came from textbooks, like standard run-of-the-mill textbooks. So you're right about that.
So I was sort of typing and, working, and I was hung up on the equations and everything, but because of this conversation now, which I think then would lead to yet another small group, in other words, we've been more enlightened by each other, I'd begin to ask questions is, does the pharmaceutical company use the model like this? Would they give a range of melatonin dosage for weight, age? You know, could you use it for multiple purposes? And you know, I don't mean the admonitions and the warnings, but just a general guidance. And, you know, one of us has a hard time, let's say melatonin, which apparently helps you to sleep and calm down, no doubt. But if you have severe problems with that, is this the thing to do? Can you overdose on melatonin? I don't know, but what I'm saying is initially I tended to get hung up on the mathematics, still stuck there. And then finally we decided, Andrew and Eric and I, to move beyond that. And it may take a little more time for some of us, me in particular, to move beyond it.
But one thing that I want to point out is notice a big thread with all of you. You actually drilled into the model. So we asked you to think about the ethical part and you drilled into the model.
That's right.
When we teach, it's really hard to get students to drill into the model. And asking them these questions allow you to have them really think about, what does this term represent? What is beta here? Like, what does beta do? You know, or whatever. Like,
Yeah.
and this is the thing that we have hard time when we're teaching. And just by asking this, like, on the face of the earth, on the face of the whatever screen, a relatively simple problem, you now drill in, like, put this question, you drill into the model. You actually are teaching the mathematical modeling.
And I'm going to jump in with one more thing too. What Brian, you said is, it's a very good point. There are issues with a lot of medications where they did most of the testing on men and it's not accurate for women and children and all that stuff. There are really good things. But here's the most important thing. We don't have to be the experts in that field. So we don't have to know about hormones. So if a student brings up something, all we can say is, let's look it up. Because we are not going to be claiming we know everything, but we can model proper way of investigating, proper critical thinking. To me, critical thinking is asking questions, asking the right questions, and then finding the answers. Like, we're not going to know everything, or maybe ask ChatGPT, but the point isn't that we need to know all of these different contexts. I definitely don't know all of these contexts. Even when I did that trust problem, I emailed my brother who's a civil engineer. I'm like, where do you guys use these torque topics? And then he said, oh, in trust calculations, here's a video. He sent me a video on YouTube. I learned the topic from YouTube and then asked the question. Good enough.
Are there any more thoughts?
Yeah,
About-
Korana, you said your students did not dig into the mathematical model, but rather asked broader questions of an ethical nature, or just?
So they do ask these questions, but then that it helps to drill into the model is what I mean. Is like, in general, like, if I'm not asking these questions, if I just put this question, because this question is from a textbook. If I
Okay.
just give it this textbook, they'll just go and solve it and not think about it. But if I ask these follow-up questions, and actually some of these questions that you were coming up with, are these things constant? Are they the same for different age groups and so on? Then they actually start thinking about, what does each term mean? So when you see this cosine term, then they actually see that makes sense, that it means that this is some hormone that it goes in the 24-hour cycle. Because of how it's written. It's like that has like period of 24 hours, let's say, if you still have that open. And that is something that is really hard to get them to look into, what does each term represent, if you're just asking them the problem how it's asked in a standard way in the textbook.
What do you think about the second problem? We haven't talked about it, but we have maybe a few minutes at most to just kind of see what you thought about it.
Can you put up the second problem?
It was a corral problem. 1,800 meters of fencing to which to build 3 adjacent corrals. So like 3 adjacent rectangles next to each other. I know in group 1, I'll speak for that because I was involved in that too. We did just kind of like, what are we corralling? Are we corralling animals, plots, or is this a shelter for dogs? We want to plot out what's in the optimal space for that, or are we doing cell block A, cell block B, cell block C? Maybe more thick than fencing. So like, what are we actually enclosing in this space? I'll go ahead and maybe wrap this part up a bit and just kind of say, whether you want to speak aloud or not, just what did you think? Did you find this difficult to do, or are we kind of straining your comfort a little bit in this idea? So if that's how you felt, students might feel the same the first time they encounter a question like this, which is why we are encouraging more like awareness at the beginning of this introduction of this topic, less of doing ethics, but more about just think a bigger, and while in the conversation, hearing other perspectives, they'll start to increase that awareness more.
Well, Andrew had to go and get the 5 issues that were ethical and paste them in while I was babbling about coefficients. So, I mean, having a piece of paper or some presence of those issues in front of us probably could, we could point to each other and say, but we're not paying, we're not doing this. But in the end, for me personally, it has opened up the issues that we could think beyond the equations, so it worked.
Okay, so let's see what our students are thinking. And this was from Feryâl's class, because she's had
This was Rohit's class, I think.
Rohit's class, that's right. Rohit's class, because Rohit actually has managed to teach this multiple times in a row. So he asked they had weekly ethical reasoning questions in there using this framework, and 81% pre and post. That's pretty good. Pretty good data here. And when we asked them, I'm prepared to think about who my decisions will affect and how, now students say 94% of them agree, and 34% agreed more at the beginning of the course than at the beginning of the course. If you go to the next set of data, which is when it shows up. In the future, it will be important to think about who my decisions will affect and how. 92% agree, and again, 36% agreed more than at the beginning of the course. So this is just, and mind you, these are freshmen. These are freshmen who are going to be future econ majors. So we are instilling the thinking to of like, think about what are the consequences of whatever it is that you're doing in a math class, and how this might affect everything around you, whatever it is that you're making decisions based on some mathematical modeling. So there is more interest in these types of problems from students because now the problems are relevant to them. This is the big take home, is by allowing the students to ask these questions. Yes, it's very uncomfortable, like you experienced today, but if you do this on a consistent basis, they become comfortable with it, and now the problems are their problems. And I don't have to think about every single possible scenario, because asking them to internalize it and think about who this will affect for them is now becoming more relevant because they made it personal to themselves. So the second thing is For most of them, this is the first ethical reasoning experience in math. So we are now building building some good habits going forward. Because if you do this for the whole class, and then if they have you again the next quarter or next semester, now you built habits of always reflecting on it. The next thing is it actually improves analysis skills, because every time now that you have a problem, you just don't dive into solving, you start and think about it. You think about what is each term? Does this make sense? What do and Rohit actually saw significant improvement in the second. It's a small sample because when we're building our samples, but it's a significant improvement when you see students term after term doing this practice. Okay, so the main takeaways are that, you need to do this in groups. There was a reason why we put you in breakout rooms, because wonderful conversations happen when people talk to each other, but we also need to get our students talking to each other. And they work better with applications. But if you don't have application, that chorale question is a standard question that we've all given in pre-calc or calc classes. You can ask students to put the context on it. And now a problem that looked like a standard, like maximize the area or minimize the area or whatever problem, now becomes a problem in context, and students now can see that math is relevant to not just mathematicians. And when they're contextualizing the problem, they can also add ethical prompts. It goes naturally hand in hand. And one of the big things that we are trying to claim as a group is that there is no good math modeling without considering ethics. So considering ethics is because it would prompt you to maybe change the model, and consider, is it, important that we look at this parameter, or is it more important that we look at this parameter, and so on. So for us, these two things are inherently go hand in hand. There is no separating one from the other if we're talking about mathematical modeling. So with that was the last thing that I wanted to say. So I wanted to thank Aaron and Rohit, who are our collaborators, even though they're not here. Catherine, Victor, and Rochelle got a grant that brought us all together. This is how we all met each other. And then at this big meeting at MAA last year, this is the list of people. I'm not going to read all the names who were also at that meeting and who formed their own groups and are thinking about different ways also of bringing ethical reasoning into math. And then here's the grant numbers. So we also, if you were in those, when you were in breakout rooms where you had your problems to consider, we also put a link with some of the resources that we are using. So feel free to use those. And we're going to open it up for any additional questions that everybody might have.
Well, first of all, thank you very much. It opened, yes, I would agree. It opened my eyes, and I liked what Korana said, that it's hand in hand. The fooling with the model and modeling itself, and then asking these questions. If you go hand in hand, they will cause you to revisit the model in context. And but I have a cynical question. One of the resistors against modeling itself is you can't cover the material. So now you folks come along and go, not only do we want you to do modeling, we want you to do this intertwined and natural thing called ethical considerations. So my colleagues are on my case because they don't know how to use an integrating factor, because all you did, Brian, was dilly-dally with models. And now, Brian, you're dilly-dallying with all this ethical stuff. So how are we going to both answer the cynics who say, and who are obstacles in departmental meetings, who say, no, we can't do that because, civil engineers want this topic covered and we don't have time. How do you?
Well, my answer, and I have gotten those questions, is my answer is like, well, are you teaching them how to build a model? And then usually answer is yes. I was like, well, you're teaching them how to build a model. You're just asking them to reflect on what each term is. And my question is like, do you give them a test question where it's like, say what each term in this differential equation represents? Yes. Well, that's what we are talking about. We're just practicing it, asking these additional questions. So it's, because we are also mathematicians, so we know what other mathematicians who are cynics like to test students on. So we can use that as the
As the lever.
exactly.
Okay. Well, thank you.
So I have another cynical question. I mean, so these, and I think, so, and another thing, so just, because I think without being explicit, I've been asking these kinds of questions for a long time. And one of the things that I would say is, for me, using technology enables a lot of these things to be done where, like, I would also tell some of the cynics who say, well, you're not teaching them how to use an integrating factor. And I'd say, well, how much do they really need to know an integrating factor? So my cynical question is, so you give the students these prompts and say, write a little couple sentence essay. And I think the advice that these should be done in groups is great. But when it comes to assessment, because one of the things that I found is that if I don't assign points to it, where there are a varying number of points to it, depending on quality, the students don't think it's important. So what kind of assessment do you really do? And do students get bad grades for messing this up?
So I'm gonna let Feryâl talk about it because she's about to click on.
But by the way, I want to interrupt. We are not cynical.
No, I know, no, but
You're probably preaching to the choir here,
yeah,
but
we need to
think
talk
there-
about cynics. We
Yeah,
do
yeah,
need to talk about cynics.
Yeah. So in that folder that I just got from the link, the main page that we had sent you in the group work, we have lots of examples, and I'm trying to find which ones were the exam questions. I had this semester, I asked them in the exams. So this is midterm problems in class or take home. And some of them were practice midterm problems technically, but they can be used in any of the midterms. So the first one was a Cobb-Douglas problem that one of my, and I don't have the references to these because I don't remember where I got them from, some textbook long time ago, and I had been using them for a while. So you have a table and then they estimate partial derivatives and then do a linearization and then estimate the second order. And then they give real life context, and it has to be a reasonable real life context. They have to explain their context. That's one of the things that I usually get. They don't explain the context. So I'm like, context is missing. And then they have to give me assumptions. I'm not an economist, so I'm actually not sure if their assumptions are terribly meaningful sometimes, because sometimes they go into the economics direction, but they're reasonable usually. So I'm like, they have to be reasonable. There is so many things, and this was only, I want to say 5 points. It's not part E, but part E would have been only 5 points. And I'm asking them to write 5 different things where each of them is a point. So if it's good enough, then it's 1 point out of 1. But if it's missing, it's not there. Or if they just, I think they were supposed to list assumptions and parties and how they might be affected. If they listed the parties, but they did not describe how they might be affected, then they lost that point too, because it's not there. I can't give them a point for missing information. So I did ask them in the exams. And I
So,
asked them,
so you gave them specific instructions. You didn't give them this broad panoply where they have to grab things out of the sky, which makes it easier for them, I think, to do that. That's great.
Well, yeah, this is my part E. This is the simple version that I'm using. I came up with that because I'm like, these 2 semesters are going to be really busy for me. So I have to come up with a simple way of doing. Consider now a potential real life, what assumptions are being made. List some parties. Sometimes I put numbers for how many parties I want. Sometimes I'm okay if they list 2. But there was one problem where I asked for 10 because of the earthquakes. I gave them the trust problem that was in an exam. I should go back to the previous one.
Okay.
I gave that one, and then I asked them to come up with 10 impacted parties, and they totally did. They came up with if the building collapses or if the bridge collapses, they thought about the emergency personnel, the people who are on the bridge, who are under the bridge, and the city who's gonna, or city or state who's gonna have to rebuild, the company who built the bridge, the construction workers who are working on the bridge when the bridge collapsed, which sadly was a true case. And then I don't remember, people came up with 10 different impacted parties. That was this problem. Okay, come on. My buttons will work. So there's a civil engineers do trust calculations, and then consider now a potential context. What assumptions are being made? List at least 10 possible parties. The more the better. I don't think I had anybody who came up with more than 10. Well, close enough. 10 is good. So.
Yeah, Feryâl, the Google Drive that you've been referring to that you sent our small groups, is that publicly available, or is it?
Can be shared with anybody, yes.
Okay, can you make sure that the total drive is in the chat, or did you already do that? Because when we list this video, I'd like to put that URL there, if that's okay.
Well, so here's the question for you. Do you want us to remove your, because that whole drive also consists of what you were doing in breakout rooms. We can remove that part and then share it.
Yes. Yeah, and the same, Lee, well, we can talk about that later.
Yeah.
Any other questions or issues? Because we're just about beyond our 5 o'clock. I
Thank you
think,
all for coming.
yeah, I really appreciate your causing me to think. And I believe I am speaking for all of those who've been here. And we wish you well in your mission, and we hope to hear more about you at various meetings in Indianapolis, at MathFest, and at our expo next February, and beyond that. So we're very pleased and proud of you.
Thank you for inviting us.
Okay.
Thank you.
All right. Thank you very much. I'm going to stop the recording. And